It is my pleasure to present our research at IASS 2021. I'm Makoto Ohsaki from Kyoto University, Japan, and co-author Kentaro Hayakawa is my PhD student. The title of my presentation is Non-parametric shape design of free-form shells using extended Gauss map and discrete differential geometry. The purpose of this research is to propose a shape design method for free-form shells using extended Gauss map utilizing geometrical invariants of primary or design surface. The discretized forms of Gaussian curvature and mean curvature are used, and we minimize the area of the extended Gauss map to obtain a surface with desired property. So this way, complex derivation of curvatures of parametric surface is avoided, and the numerical example shows that the various shapes of free-form shells can be found using the proposed method. Gauss map is a surface on a unit sphere generated by unit normal of a design surface. Here, S and T are the parameters, but we do not use the parametric form in this study. An invariant of surface denoted by F is multiplied to the unit normal vector to generate an extended form of Gauss map. Then free-form surfaces are generated by minimizing the area of the extended Gauss map that is defined as the integral of determinant of the first fundamental form. We discretize the design surface into a polyhedron with triangular faces and define the normal vector at each vertex. Then the design surface and extended Gauss map have the same topology, and the area of the Gauss map can be computed easily. The Gauss map of triangular unit of convex surface forms a triangle as shown here, but it may degenerate to an arc, line, or a point as shown here. For example, if the design surface is a cylindrical surface or a piecewise developed surface, then the Gauss map becomes a line as shown here. So a piecewise developed surface can be generated by minimizing the area of the Gauss map. We use the definitions of discrete differential geometry. Gaussian curvature and the mean curvature vector are formulated as shown here. The mean curvature is defined as the norm of the mean curvature vector. This figure shows the variations of the square of Gaussian curvature and the area of Gauss map with respect to the height of node A here of the square unit. We can see from this figure that the area of Gauss map is more sensitive than the square of Gaussian curvature. So a better convergence may be achieved by using the area of Gauss map. Free-form polyhedral surfaces are generated from the initial surface as shown here, and three types of extended Gauss map are considered. The first type is the Gauss map, and the second type and the third type multiply Gaussian curvature and the mean curvature respectively to the unit normal vector. For type 1, various piecewise developed surfaces are found from the initial surfaces randomly perturbed from this shape as shown here, and each one of 4 equal parts of surface A consists of diagonally placed 2 planes, and the surface D consists of 2 planes. So we can see from these results that interior boundaries of the smooth surface patches are naturally generated using the proposed method. For type 2, a symmetric surface with plane patches are obtained from the symmetric initial shape, and a cylindrical shape is also obtained from another initial shape, as shown here. For type 3, an HP surface is generated, as shown here, by multiplying the mean curvature to the unit normal vector to generate an extended form of Gauss map. Finally, I'd like to conclude my presentation. In this study, a method has been proposed for shape design of freeform shells by minimizing the areas of the extended forms of Gauss map. In our method, complex differentiation operations of curvatures and integration along the principal curvature lines are not needed by using the formulations of mean curvature and Gaussian curvature in the framework of discrete differential geometry. It has been shown in the numerical example that various shapes of piecewise developable surface can be obtained, and the interior boundaries of the smooth surface patches are naturally generated using the proposed method. Thank you for your attention.